Well, Ignacio, I tested a couple of times, and I was bang on 7 minutes.
Okay, well, here we are, which is the most important thing.
Okay, it is 9:30 here in Montreal. Thank you everyone for being here. Welcome to RASPRG. As I said before, this is a big room. If you want to come closer, we're going to have a panel today, so the speakers are going to be up at the front, and we hope this will be more interactive, so we can have a better conversation. Ignacio, you have control of the slides. Oh, okay, you want me to go through them? Okay, great.
As you wish. If you're there, I think it's going to be easier.
Okay, no, that's fine. I'll let you do the introduction of the panel later. This is the Note Well, which you have probably seen in other sessions, but take a little time to read it anyways. It talks about intellectual property in this page. There are also other things that you agreed to when you registered to participate in the IETF and RASPRG meetings. So please keep that in mind as well. I'm going to take over the control of the slides because it is a lot easier to do it this way. These sessions are being recorded, so please keep that in mind. We use the sessions so that we can have the participation online, that we can have recordings for later. We're going to take transcripts and minutes from them as well. One of the important parts of participating in the IETF is, of course, the code of conduct and the ability for everyone to remember that you acknowledged when you registered for the meeting that you are going to abide by the code of conduct of the IETF. There are some RFCs in here also listed. Please take some time to go read them. If you have any questions, you can ask any of the chairs or the IETF chair as well. So the goals of the IETF is to focus on long-term research issues that are related to the internet. It is a parallel organization of the IETF that, as you know, focuses on shorter-term engineering work. We here in the IETF conduct research. We are not a standards development organization. This working group in particular is, of course, related to the standards process, which is great for synergies between the two parts of the organization. But the goal, again, is not to produce standards, even though there might be some work that could become not only an RFC, but could eventually go to the IETF. If you are new to the organization, you can go read RFC 7418, which has a lot of good information about the IETF and its goals. Here in RASPRG, we are working on getting an understanding of the standardization process through evidence-based reproducible work, of course, research. We can do outputs in terms of papers or other tools, open software, things like that. We are not trying to compare necessarily the IETF to any other standards organizations or directly influence the IETF operations. Even though if we're looking at how the IETF work and researching on that, there may be some insights that the IETF could use. But the final goal is to get those insights, and if we can give it to the leadership of the IETF, yeah, that's a good thing. So we are not directly influencing policy or have a goal of changing how the IETF or other SDOs work. You can read more about RASPRG and look at our past meetings and read the minutes and everything else at the link below. Ignacio, who is online and is the chair, I'm his co-chair, Alvaro. Here is, if you are not in our list, you can join the list at the link that we had before. Here's the link again already. make sure that you scan the QR code so that not only we know that you're here, but most importantly, so that you can participate and join the queue and participate in the panel. As I said, today we're going to have a panel. It would be great if we can also get someone to volunteer for the minutes. If you haven't seen so, there are a couple of experiments that have been active going on doing minutes. Jaime, who's one of our speakers today, has some tooling. There's something else that has been circulating for this meeting specifically. So nonetheless, it is important to have people involved in the collection of the minutes. So if anyone wants to volunteer, that would be great. Not all at once, but okay. So here's today's agenda. The first part, which we hope there won't be a lot of, is the agenda bashing. We already went through the opening slides. I'm going to hand it over to Ignacio to introduce our panelists, and then we're going to start the panel. As you can see from the agenda, basically the whole session is about this. So we expect robust discussion, not only between the panelists, but you guys in the audience, please ask anything you want, and let's have a good discussion about the topic. Ignacio.
Yeah, thank you very much, Alvaro. Yeah, so we have had a few interventions, papers, and presentations about using LLMs in different ways in the context.
Yeah, Ignacio, we need you to speak louder.
Oh, sorry about that. Can you hear me better now?
Yeah, I think that's a little bit better. Maybe even more if you can get closer.
Okay. Well, this is as close as I can get.
There you go.
Fantastic. So indeed, we have had a few presentations in this group, also in NRW, and a few discussions on the mail list about LLMs in the context of the IETF and more broadly on standardization. So we thought that it would be a good idea to bring some of the people that have been having those discussions and see what can we get out of it. So we are going to have now a panel on how does standardization look in an LLM-enabled future. So the plan is to have 7 minutes for each speaker and then to have a discussion. So the first speaker is going to be Jie Bian from the University of Oslo, who presented a paper this summer in Madrid about LLMs in ANRW. Then we're going to have Jaime Jimenez, who presented his paper on RASP about doing summarization of IETF conversations. Then we are going to have Joseph Potvin. By the way, apologies if I mispronounce any names. And finally, we are going to have Jean Keralt. And with that, let me give the room to Jie, who is the first speaker.
Okay, it's my turn now.
Yes, go ahead. And you should have control of the slides too.
Okay, so I should start present. Because the timetable side starts from 50. Now it's not 50 yet. Okay, I will start. So first, thanks for the invitation. And I'm going to talk briefly about my research, automatic mining of mailing list for Internet protocol design decisions. So IETF hosts a lot of text resource. So that means there is unlimited possibilities between IETF and large language model. So the motivation of my research is to understand the rationales behind the design decisions. So RFCs serve as cookbooks, and they define a lot of decisions, but they may or may not give the explanation for why things are the way they are. But understanding the why is very important. And luckily, the why information was documented somewhere else. They lie in the email archive, GitHub, or meeting minutes. So we want to find the why information from the email archive. And to the best of our knowledge, there's only one RFC after 8374 that officially document the design decisions and the corresponding rationales discussed for a previous published RFC. So how we can utilize the IETF textual data? The dilemma here is RFC defined decisions, but they do not usually contain the rationales. And the emails, they have the rationales, but they may not explicitly mention the decisions. So that means we cannot utilize the email directly out of the box. So we start with manual annotation, but it turns out it's quite time consuming. So we move to the GitHub repository. The GitHub repository can give us more automatically labeled data. And now we're coming back to the emails because nowadays, as the fast involvement of large language model, they are capable of doing more complicated tasks. So specifically, we asked large language model to recover the missing design decisions discussed in the emails. And accordingly, we create a semi-synthetic data which contains the pairs of decisions and the rationales behind it. So here's an ideal example from RFC 8374. So this document has altogether 46 pairs of decisions and their corresponding rationales. And the rationales was concluded by the author himself after he checked back their email communications. So that means for this specific decision, withdraw or not sign, there exists at least one email in the archive that contains the explanation regarding why they determine withdraw or not sign, or all sign or other options. So the problem here is how we can find such emails. So our method, we leverage a very well-known existing natural language processing technique called information retrieval. Information retrieval is very helpful when you're trying to find the target from a large collection of documents. And it works by comparing the queries against a lot of documents by some matching functions. But different from the traditional information retrieval, we leverage language model here also. As everyone knows, language model convert the textual representation from the decisions and the emails into a high-dimensional vector space. And afterward, we can compute the matching functions in the information retrieval and rank the email according to the relevancy to the decisions. And that's how we can find the relevant email discussion for these specific decisions. Oh. So here is an example from our created GitHub data. This is a quite straightforward demonstration regarding how the data look like. So we have pairs of decisions, pre or post version, and their corresponding comments. And the decision was modified according to the comments. And we leveraged the previously mentioned information retrieval to help us find the relevant discussion regarding the specific decisions. So as an extension of work, since we already have this data, so why not we just leverage the large language model to do more tasks for us? And the first thing we thought of is to leverage it as an auto editor. So now we expand the work from GitHub to email archive. We ask the large language model to restore the missing decisions, and we continue to validate the effectiveness of our approach on the email data. So the email discussion is kind of in free format, and the opinions are distributed here and there. So we plan to continue leverage the large language model to generate some formal explanation regarding the design decisions. And the whole work pipeline works very much like the retrieval augmented generation, short for RAG. And that's it. Thanks for listening to my presentation. And we have published our data and models on Hugging Face. And we also have some published papers regarding how we trying to solve this problem. Yeah, that's it. I think I managed it within 1 minute. Yeah.
Yeah,
Thank you.
fantastic. Thank you very much.
Oh, thank you.
So next in line, we have Jaime Jimenez from Ericsson, who presented here also at RASP his pipeline for summarizing IETF meetings. Very cool tool, by the way.
All right. Is it okay? All right. So good morning, everybody. So I'm going to be talking to first of all, as a disclaimer, I'm not really a researcher in the topic of standardization processes, but I work in standardization and I work with AI. And I'm just basically going to be telling my experiences in this domain. This is the summary, by the way. Do not delegate understanding on LLMs for those of you doing standards. So the premise here is that the AI is a tool to delegate tasks. You cannot delegate understanding. You need to validate everything that comes from the AI. It cannot understand the spec for you. It cannot understand implementation for you. And the moment you start using these tools, it's very easy to get ahead and keep using it. But basically, the AI will be as good as the person using it. You need to know the specification to validate whether the output of the AI is actually useful or not. But delegation can be very powerful, and personally, I use it as a way to speed things up in some of the processes. As GA was mentioning, we have fantastic open records in the IETF that are already machine readable. This doesn't include also the transcription tool or the IETFmeetings.org that has been just created. It's also really great. So we have more of that. And they're all searchable and addressable. What I see is a bit of a convergence in practices from developers, generally in the industry, and the way IETF processes work. So, for example, or a standardization. I say IETF, but this could be happening also in other organizations. So here in IETF, we brought GitHub a few years back. It had been in the industry already for a long time, but we kind of already adopted it. Everybody has built a chatbot that is provisioned with access to RFCs or drafts to provide you information. And similarly, in the industry, you have dedicated knowledge bases that are fed to chatbots for various things. What I haven't seen in the IETF yet is, for instance, in the CI/CD pipelines, to have in the backend some sort of agent processing the commits to a Markdown file, as an example, and giving you feedback. I guess it will come over time. Similarly, testing and quality processes, we do it for code. I think it will probably come for RFCs or for documentation as well. So think about it, you do a commit and maybe the backend is checking that if you put a must here, it actually is, you didn't make a mistake 2 paragraphs below and made it a may, or, like the various things you can check in the text for compliance, for consistency. And then another trend, well, back last year was all about LLMs and GenAI in general. This year has been about AI agents and MCP and exposing things via these interfaces. In the IETF, maybe there is, but I think it's maybe like an undercurrent that some of us are using, but I don't think it's mainstream yet. But I believe actually all of this will come. What can you do today? Alvaro mentioned, I presented in here some experiment I was doing for generating reports with AI. Now you have, as I mentioned also, this IETFminutes.org that is really neat and is known from the transcript. The transcript in the IETF has become much better, so you can use it. Couldn't use it that way maybe last year. Still makes mistakes with foreign people like me. Maybe they don't know how good the transcript is working right now, for example. But you can do, for instance, what I do also, I use it for editing and reviewing documents as well. So you can process detailed review comments, you can do consistency checking. And although you can use MCP tools, the nice thing is that most of the documents, most of the stuff in the IETF is already public and it's static pages. So you don't need dynamic queries to APIs. It's just literally, you can even download everything locally and use it locally. So this is an example. I don't know if you can see it too well, but this is an example of how I use it. So on this side, you have Claude. This is the document. This is the feedback that I got. this can get pretty large. So the document itself might be 30 pages or more. This is 80 pages feedback, super detailed. So context switching and bringing this to your head actually takes a lot of time, but many of the edits are not that, do not require that. They don't require architectural thinking. They don't require rethinking how you have done things. It's more like a lot of mechanical stuff. And for that, you can use Claude. It can suggest, so you load everything in Claude, you put whatever MCP stuff you need, you put all the interfaces, and it will suggest you, and the nice thing is that it organizes everything pretty neatly, and then you can go step by step on the basic things that are actionable directly. And also, for instance, in this case, I'm checking the initialize function and the edit, so I approve all of these things before they happen. I can modify them, but the nice thing is it also notices other parts of the document where that thing is being used, which is neat because you tend to forget that. If you have 38 pages and you're going through everything, sometimes you forget. So it's really useful, something that may take 20 minutes, it take me a couple of minutes. It still can be wrong, you still need to check it and be thorough, but these are definitely a step forward with the state of the art. And I think this will catch on because it's how developers work already. I mean, vibe coding is kind of like that already, so I think it will happen. What are the challenges? So same as with coding. So this is LLM based, so you still get hallucinations and mistakes. And with agents, you get compound errors. So you need human in the loop at every step. Then there is a lack of established best practices. I think, again, they will happen little by little. They need to create, and also you need infrastructure to run. You need some GitLab runners running these things. You need the AI access and all that. But it will probably come, I guess. It depends on depends on the last bullet, which is the adoptions. I think there's a lot of resistance. There's a lot of people that haven't, that don't use this, and they don't need this, and it's totally fine, by the way. But there is an underlying maybe mistrust on the use of these tools, and it's understandable as well. But the patterns are there, and I think it's a matter of optimizing and using it if you want to use it. Personally, I find it very useful. And yeah, I think that's more or less like my story about this. Thank you.
Thank you, Jaime.
You, Jaime. And our next speaker is Joseph Potvin, co-founding executive director of the not-for-profit Algorithm Foundation. So the room is yours, Joseph.
Let's see, there we go. Hi, what I'll do though, first, let me see, I need control for the slides, there it is. So I'll just explain the rather long title here. First, I start off by saying tilde AI, which is apparent intelligence. I don't trust them to be intelligent. Using LLMs to transform IETF standards into rules of data using an application called RuleMaker built in Svelte.js for dynamic discovery and conformance checking using Rule Reserve, which is a network service with nodes and IPFS, either or your own network. Use WebSocket, and soon it'll have MCP as well, so that you can do conformance checking as part of unit tests using rule takers, about 200 lines of code of functions in your own programming environment. Once again, WebSocket or MCP sending the messages. I put the names of several other people, but I won't give all the credits here. It's online. Also, my presentation goes into a lot more detail than I'm going to speak to, so anybody can refer to it later. Let's see, there we go. So I'm going to use an example, BGP4, that's RFC 4271. This is a dissemination of routing information on through routers. Specifications are in precise prose, very rich in meaning when they're read, but very poor to use, very poor in utility when you're actually writing code for these. Long form doesn't scale well. It's hard to comprehend at the beginning, but you can work at it, but it's very difficult to recall exactly. Wouldn't it be nice if we had a way to transform the 200,000 rules that are embedded in something like 5,000 active RFCs into a library of data structures that are consistent so they can be dynamically discovered, displayed to the programmers or displayed to anyone else doing conformance checking, and run without injection risk during unit tests from any programming environment. So what I'm going to be showing you is some of the how-to. There's all actual running code to do this. It starts off with expressing the rules with a finite grammar. This goes all the way back to Noam Chomsky in the 1950s, but we have 6 grammatical elements for each sentence, 3 of which are required. 6 are used for complete sentences when displaying to a human. And there's also bisemantic four-value logic, but I mean by that it's bisemantic because for the input conditions it's no, yes, yes and no, yes or no for the logic gate, and also on the output assertions it not, must, may, and should, which is BCP 14 words. I'm not going to go into details here. This is actually just a screenshot from RuleMaker. So we have the input conditions and the output assertions on the left-hand side, and the logic is on the right. So I used Venet's AI to do this. I find that the more sophisticated LLMs are not as good as the simpler ones. Venet's was best at basically I just use these as linguistic aids, not to interpret anything. I just use the LLMs are actually linguistic tools, so I use them as linguistic tools. All the input conditions, output assertions are expressed in the same 6-element finite grammar. As I said, the logic is on the right-hand side. And you read this, the logic vertically. So there you have no, no, yes on the top, and must and no, not on the bottom. Let's see, I'm trying to find there we are. And we also structure the output in a very particular way. It's a sparse array. We call the data with direction array. This is only used as a transient representation in memory. It's a key value sparse data structure. And the key combinations are all listed at the top, and the values are at the bottom. So I'll show what this looks like, even though it's and then this is, since that's a sparse array, we condense it into a data with direction coordinates list. So that just replaces all the zeros, gets rid of all the zeros and replaces the ones with column index numbers. So that's the kind of a generic representation. Here's the BGP for dissemination rule in this form. The LLMs, I use LLMs to aid in the sentence drafting to get it kind of shoehorned into that form. It's stored and will reserved this way with a package of metadata. So the metadata is also in this form. We use bars as separators. LLMs are used, they're quite convenient to do the drafting of 100 character, 240 character, and 960 character title, summary, and explanations. We include that as metadata so it can be displayed to people. And then RuleTaker sends an is message and then receives an ought message. The ought is basically all of the rules that are in effect and applicable, in effect for time and jurisdiction, and applicable to the categories that were provided. And then RuleTaker receives this as an OUT1 message and uses local circumstantial data to sift it to find the output assertions from the logic gate. It structures an OUT2 record so that that's available for display to a human or to give to a machine. It can be run as is with a parser source in the substrate application, or it can be transcribed using an LM if you want into any code base that you want to use, say in a rules engine or something like that. That's a quick summary of how we do it. So I showed a lot of detail in this presentation just because on the slide, because if anyone wants to go back and see how to do this, all of it is running code. The part that we're currently working on is the MCP integration so that rules can be discovered and pulled into the application that you're using. We don't intend that the simplified sentences are a full expression of the RFC. What we do is we provide basically anyone on a machine gets a summary, and as with laws, the actual source document is the reference document. But this provides a way, by the way, I've tested this, giving even basically any generic LLM, I can give it a few examples, and then they can start to structure the coordinate list representation of a rule, of a bunch of rules out of a RFC fairly automatically. It's always a human in a loop to double check how this goes, but we can actually scale to do all of this.
Thank you, Joseph.
Fantastic. Thank you, Joseph. And last panelist, we have Jan Carroll, founder and CEO of the IO Foundation. So over to you, Jan.
Good morning. Is it working?
Okay, now.
No, okay. So I just realized when you were making the introduction this morning that that I may break a little bit one of the rules of the working group. We'll see what happens. So I wanted to talk to you today about prompt run protocols. And the idea of one of the origins of the organization that I manage, which is an NGO working on technologies, was this particular joke that I still remember today as to be the most funny nerd joke. And so, okay, so we have a number of things coming up. Everyone has a mouthful about LLMs, agents, whatever is the next buzzword we're going to be getting in the next months. We are always looking into how they're going to be affecting the way we function. And the question we were thinking about ourselves is how it's going to be affecting the IETF and the way the IETF works. So, sorry. The big word in the IETF is essentially to achieve interoperability. That's what we work for. We try to have protocols that are going to be serving as many use case scenarios as possible to ensure that people can communicate with each other at any point in the globe. All right. So how do we do it nowadays? Is we do a lot of collaboration. We do a lot of mailing lists. We fly to several places around the year. We talk to each other, and we try to figure out those compromise situations that are going to be allowing for that interoperability. And the machines, no matter how much we are working on them right now, they still need us for some degree of consensus. Now, are we going to be reaching a post-consensus era? Whereby, am I going to be able to basically prompt what is it that I want to achieve in terms of communication and leave it to a swarm of LLMs or SLMs to do it for us? And how would that look like? What would be the consequence for the way that we are understanding technology at the moment? And the way we are calling them at the moment is basically prompt run protocols. At that point, you don't have machines that really require you to be able to establish that consensus in advance. What you require is a different way of looking at things. So what we have right now, if you think about the evolution of coding, for the programmers in the room, which is, I'm assuming, most of you, you used to learn a language, a series of statements, a series of operators, to be able to prompt a compiler. Now you are basically moving into a natural language processing, and you're still prompting an LLM. There's not much of a difference, really. And so there's precedence about what LLMs have been, how they have been used and how they may be shaping the IETF and other elements of standardization in the past month. So Jerry's work that he presented in Vancouver in 120 was very clear into how they managed to train an LLM to behave like an Apache web server. I don't know how many of you were participating in Madrid, but there were a ton of side meetings where the impact of LLMs and AI were discussed in terms of how this is going to be either helping some of the processes or even changing how the way we're understanding things. And one thing is not for nothing, but an RFC, even if in the previous presentation it was made clear, actually the timer doesn't seem to be on.
Okay, I'll get it up.
Okay, I don't want to be over time. They may not be perfect, but they are essentially a prompt. So come again?
No, go ahead.
We good? So what I'm getting at is that we have the very strong feeling that we're going to be moving into prompt run protocols, but that's not going to stop there. What we understand nowadays as vibe coding is very likely going to be prompt run applications, and that nothing really stops to go to the next level, which is prompt run organizations. And if you think about it, it sounds like science fiction, but it is exactly what we do nowadays. What's a bylaw? It's a prompt for a bunch of humans to follow. What's a strategic plan for next year for the company in order to reach some sales KPIs? It's still a prompt for a number of salespeople to go and act. So just change that by LLM, and there's no actual reason as to why you're not already doing the next thing. And so some time ago, I was thinking about what Clark used to say on any sufficiently advanced technology is indistinguishable from magic. And that made me think about, for the nerds in the room, the Middle Earth. So what we seem to be building at the moment with the technology that we have is this abstraction layer of magic. And I want to remind you that no one really knows why this building is not collapsing in our head. For us, if you think about the technology that is involved or the mechanisms that are involved for us to be able to enter into buildings, it's nothing short of magic, really. Or you being able to go to any restaurant and consume a lot of food without having to concern yourself as to whether it is edible or not. You assume that it is. All the processes are transparent for you. And so the cool thing is that Clark did think about this, how this is magic, this click thing that I'm using for someone 30, 40, 60 years ago. They wouldn't really understand how it works. And eventually, I actually don't even care how it works. It just works. It's not my concern anymore. But the funny part is, even magicians can only be magicians if they learn the proper spells. Aragorn is not able to invoke an elemental. Only Gandalf is. And only a specific trained Gandalf to be able to do that. So what I'm trying to get into the point is that, yes, we are going to be prompting. We're going to be having to learn how to prompt specifically. And what does that get is that I have the sense that if the IETF wants to take up into this kind of work, and this is where I might be breaking a little bit the protocol for RASPRG, I would not see impossible that the IETF starts considering becoming the Royal Academy of the Technical Language. Because as the previous presentation was showing up, we are going to need to be able to structure those prompts in a way that are going to be intelligible and reproducible across every single party involved. And so questions that I have are, is this the end of protocols as we know them? What role would have the IETF in this kind of evolution? How far are we from this scenario? I don't think it's happening tomorrow. I just don't see a counter argument as to why it wouldn't happen. And what do we need as a community to be able to prepare so that it doesn't bite us back and put us into irrelevance? So questions would be, do we want to have a research group on this topic? Would it be possible to structure RFCs moving forward so that they are much more easy to ingest by an LLM in ways that are much more standardized? Would the IETF want to become a bit of a reference on this? And then the actual behavior of the LLMs, agents, whatever the hell, would we want to also have ways to standardize? Because we need to make sure that the output is going to be consistent with what you want to achieve. And so after what I just said, maybe this joke hits a little bit different, because obviously we actually get to control what's the source code, so we get to change the world in a way. Thank you.
Thank you. Okay, thank you to all the presenters. That's very, very interesting. So as we said at the beginning, this is a panel. So what we're going to do is have you two who are here in the room sit in the front, and we have, of course, the other two presenters already in the front up there. Yes, thank you. So the structure that we have planned for this is basically an open conversation. There are tools that you presented. There is this vision that everything is going to change and we're going to become the Royal Research Academy of Language, the IETF, I guess, is the name for us. Let's start with something, I guess, easy, just to start the discussion. But I would love to see discussion between you as well, the panelists, not just prompted from questions from us. If anyone has a question, please get in the queue. What do you think are the barriers for us to get there? We see tools out there. Not everyone is adopting them, but it feels like that we may be reaching a point of a waterfall, where there's no adoption, no adoption, no adoption. All of a sudden, things get adopted, and we not necessarily fall off the cliff, but get into a different reality at some point.
Maybe I can start. So when it comes to so AI tools in the industry, they are used already extensively in the development organizations. The driver is mostly automation and efficiency, but developers, from what I have seen, usually when they start using these tools, they don't want to go back to previous practices, and they are very useful. I mean, that's undeniable. A lot of code is being generated by AI. They have those practices already enabled. So it's kind of like, in my opinion, at least a logical step that it would go to other practices in the industry. So standardization is one of those. And yeah, the main, as I put in my slide in the last one, like the main roadblocks I see, there is no best practices, because standardization work and writing specifications and all that is not exactly the same. It could be that in the future you just write the code and then the agent writes the spec for you or something like that. I wouldn't be shocked. But today it goes the other way around. You write the spec first and then you do some basic implementation. And yeah, so there is no practices, and there is no there is implicit non-determinism in the way agents work today. Maybe they will fix that somehow. I don't know. It's not my thing. But as something that you use with human in the loop, I can see value for it today already. So it's just that it's maybe not mainstream, because not everybody doing development is doing also standardization, perhaps. Yeah, and then towards the far future, I don't know. Like what I'm talking is maybe like 1 year, something like that, 1, 2 years.
I think that
Joseph, you're in the queue, but you can go ahead and speak.
Can you hear me?
Yes.
Yeah, so first I'll just emphasize what Jaime said, do not delegate understanding, and there's such vast differences between the kind of intellectual process someone goes through when they're actually studying a detailed standard, and the kind of interpretation that a linguistic tool such as an LLM could possibly do. I use them a lot, but I mean, I'm quite conscious in not using them for delegating understanding. In fact, in my former work, I described the method that I use as artificial naivety, and I find that very effective as a way to go. They're functional tools. In terms of barriers, I think that, well, I guess what I dedicated a whole bunch of time to over the past few years is creating the methods required to make the substance of these rules available both to the human brain in the way that the human brain wants, including references to the original, so that somebody who wants to do the deep dive can actually understand the human style of logic. But then also, the key thing is to prompt people to realize that there is some rule that's relevant to the particular work that they're doing. Every other approach to rules automation I've seen requires that the rule taker needs to know about the rule in order to make use of it. We don't assume that any particular programmer is going to be aware of all of the particular standards from IETF and IEEE and ISO and so forth and OASIS. So this enables a scaling, us to scale how these things are structured for those automated prompts, and then with the direct links back to the source documents.
Yeah, thank you. It looks like there are two different fronts in which people are using it. Like, for example, Gia and Jaime were showing how you can use it to kind of follow up the conversations, whereas maybe Joseph and Jen, you are focusing more on how you can do the standardization themselves. So I'm wondering whether you foresee people adopting it more or faster in one way or the other. Like, for example, I could imagine someone just putting a thread, a conversation to stay up to date on a topic that maybe is not core to them, but they are curious enough, whereas people might be a little bit more adamant use it for something that is more directly involved in standardization.
So I would say that as we are getting better in those technologies, the transition time is going to be using them much more as tools at the moment, and that's sort of the logic pathway. What I don't see is how it's not going to be moving towards the second phase. All the incentives are aligned for that. In terms of whether those technologies are going to be reliable or not, I don't see how is that any difference than when you engage with a young engineer who may or may not have enough training and may or may not know what he's talking about, and you just keep correcting them over time. There seems to be this assumption that just because I'm training a model for, I don't know, 3, 4, 5 days with a set of training sets, that's it, they know everything. Well, how long does it take for an engineer to actually become an actual productive engineer? It takes a long time. So that assumption, the fears that we are having about bad output, I don't necessarily see them much different from the fear that I have of me hiring a new person and not knowing exactly how performant they're going to be. And the time you're going to be spending with them to be able to shape them into the engineer that you require for your company or for your products is pretty much the same one that you're going to have to be spending training the LLMs around you. That obviously, if we manage to do things properly, which again, I don't see how we're not going to be getting into that. Just remember that it only takes 3 people around the world convinced about this idea to just carry with it. And eventually figuring out what they need to be for the breakthrough for this to work. 15 years ago, we didn't know about GPTs. No one was even thinking about it. What's coming down the road? I got no idea. I'm not going to be playing magic ball. What I'm saying is there's more than enough people with enough incentive to try to figure out how to improve automation. And then all of these conversations that we have about alignment are not very different from whether I'm going to be interacting with people who are in the same wavelength as me in terms of principles or objectives or ways of thinking. I don't see where's the inherent difference. And so eventually the tooling part will be replaced by a new paradigm in terms of how things are done. And that's what we need to figure out as soon as possible so that we make sure that it serves the purposes of what we still want, which is interoperability at big scale.
Joseph, I think you're in the queue.
Hi, first off, how's my sound right now? Better? Okay.
Much better.
Okay, sorry about the earlier distortion. So just a comment, the way I look at what Gio is doing, what I would find more useful than I find looking at the why of standard or a particular rule useful. What I would prefer from that kind of use of LLMs on all the discussions is for the LLM to go and find the thread of conversation that might be scattered amongst multiple conversations and give me a sequence list of here's what people said, and not to summarize what people said. When I'm using LLMs on my own work in order to, like, if I'm doing I got to fit something into 300 words, I find the LLMs are constantly running interference, throwing in concepts from its training or from some MCP accessible source, and it provides useful work to me, but I spend a fair bit of time pulling out the extraneous ideas that I didn't ask it for, because what I'm doing often is it's a unique approach to some topic, and it's still jamming in all of the conventional ways. When I did the summarization for BGP4, as I said, the simpler one, Venice, didn't insert a bunch of stuff that I didn't want, whereas the Claude and Lumo and DeepSeek, they all did.
Maybe another comment in that line. So what my experience, what has shown me with the topic of hallucinations is that they become entrenched. So the more data you give, the more it could be for a non-expert as a passable output, as a trustworthy output. But when you go deep into the nitty-gritty details, there is still hallucinations. So it might be, I'm not an AI expert, but it might be an intractable problem, and it's different, it's fundamentally different from the infrastructure problem or other problems that are more like engineering, you know, like setting up the right backend or the right CI/CD or the right processes or whatever, right? And for that, yeah, I guess the industry is looking into that, into the determinism issue. But being practical for the IETF, actually, I think could be interesting to explore what could be done today. Because, for instance, I could imagine you're writing a draft, for example, and you already have backend processes, and you have already GitLab runners, for example, that compile the markdown into HTML or whatever. Like, you can have the same thing plus some, and you have also the needs, right, for your document, but to see if it is formally correct. So I could easily see an addition to that process by which you get warnings like, hey, by the way, you have been using this type of RFC XYZ reference here, but actually maybe you mean this one, or in these two paragraphs are kind of like contradictory, or in these examples you may want to look at that. Or for instance, for editorial, basic editorial changes could be also automated easily. Maybe you don't even need an AI for that. So yeah, I'm personally interested in how these processes could be practically taken to reality, and if there is actually community interest, because that might be also a question, because there is a lot of resistance to adopt new tools, as we experience with, for instance, Git.
Yeah, there is some conversation on the chat, and there's also some people in the queue. Andrew is first, then Rod, then Colin.
Hi, is that working? Yeah. Good morning. Thanks. Useful chat. Andrew Kempling. In this context, AI skeptic. I think the problem is, I think this was reflected in some of the discussion so far. Yeah, we're sort of mislabeling LLMs as AI when there's not any actual intelligence. It's just statistics, pattern matching. Yeah, without downplaying it, it's clever. But it's not intelligent in any reasonable definition of intelligent. If we use them more than just as useful automation and efficiency tools, then you have to start to question the impact of that. So if you do, train a model in lieu of training an engineer, to pick up on the example that was given earlier, the issue with that is you don't have an engineer. So in 5 years' time, when you actually need an engineer, you've just got a model. I suppose the question I pose to the panel is, if you jump early onto LLMs thinking that they're AI, then you're just hollowing out the skills that are available. Yeah, where's the innovation going to come from? Without the actual intelligence. So don't call it AI for a start. And yeah, what about the upskilling of people to actually do the proper innovation? There's a sort of question in there, I hope.
So in that regard, I feel that a key word that most people are not paying attention to is satisfactory. As in, you start implementing and adopting things at great scales when they are satisfactory enough, when they are good enough for whatever definition of purpose that you have. And so, do I think that those LLMs are going to be replacing us immediately? No, I don't think so. And I think they are very useful tools, and in that particular regard, they can actually help us with some of the process in the community and the RFC management and the two tooling systems that we see in the presentation. I find it fascinating for helping people. But as the technology evolves, so will your expectation of sufficient. And should we ever, if we ever manage that, which I don't see how it is impossible. I don't think it is now. I just don't see. The expectations that you have for engineers have changed a lot in the past 20 years. We all have these conversations, how people have less interest in universities, students are a bit more lazy, et cetera, and everyone is adapting to that. I'm not saying it's a good thing. I'm only saying is your expectations are changing based on the kind of quality engineers that you get. Are we going to apply exactly the same thing for LLMs? Possibly. If I can run an organization or a specific set of protocol procedures with something that sufficiently gives me business, what do I care? So that particular measure is what becomes very complex, because it's going to be a human interpretation as to what is sufficient. But that's where we're going to have a lot of battles back and forth into, do I accept your solution or not?
Maybe like to provide another viewpoint on this question, by the way, Andrew, right? Yes. Like just a comment. So I saw a very interesting presentation by Simon Wortley. He is the author of these Wortley maps. I was in a conference and he was presenting, and he drew an analogy with the current AI trend to try to remove engineers from the picture, and because you bring AI and blah, 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 and probably some of the layoffs are caused by that indirectly. I don't think they are replacing engineers with AI. I don't see how. But in the processes, it might be that there is some optimizations being done. But he pointed out that it's analogous to what happened with the cloud. Like at the time you had system administrators being laid off because you have the cloud, and then 2 years later they had to rehire them to handle those VMs, to handle things. I don't know. I think I wouldn't be surprised if it happens something like that as well. Like the industry is going really fast on these things, and the expectations are, we are at the top of the hype curve. So 2 years time, who knows? Eventually it has to go to the practical realm, right? So.
But quickly on that, so that was the argument that I was trying to make very, very quickly in those 7 minutes about the wizards. So your engineers may not become the ones who are thinking things in terms of implementation, but they might be able to prompt them properly and as accurately as possible. And so maybe we move into being able to summarize the ETS in the black box of your head and prompt them as accurately as possible. And then the competition becomes who can actually prompt better than others. But then the implementation may become irrelevant if it is sufficiently good for the purpose of what you're trying to achieve.
So before you go, Rod, if Joseph, if you want to also jump in, please feel free at any time to just unmute and say something.
Hi, I'll just jump in on that. So I want to emphasize too, my attitude towards this is that I think the only real, in this type of work anyway, the only really effective use of LLMs is to enable the humans to be more effective. If it's not doing that, then I don't find it interesting. I'll just quickly address a question that was raised earlier, and somebody on the chat has raised it again about how to structure future RFCs to be LLM friendly. So what I presented very quickly with too much information on the screen, but that's exactly what we're attempting to do with that. So we're not rewriting the RFCs per se, but we are providing the input conditions and output assertions for each of the rules embedded in these RFCs, so that they can be and it's a human mainly doing that with the linguistic assistance of LLM tools. Because it's otherwise hard to shoehorn the darn long sentences into discrete, simple sentences. But we get them into discrete, simple sentences, and then prompts to humans can be auto-generated, then leading the human to see a 240-character summary of what it is. And then with a direct link, part of the metadata is the direct link to the RFC. Then they can go find out about a part of the standard, some 20-page standard that they didn't realize is directly applicable to the piece that they're working on.
Looked like Gio was reaching for the mic, but maybe not. Hi, Rod Van Meter from Keio University. So also in this context, I guess I would probably count as an AI skeptic, but man, there's been a bunch of really interesting stuff said so far. Particularly, I like the idea of don't delegate understanding. It's a great way of putting it. A lot of this around reprocessing or repackaging the RFCs or finding the material within the RFCs, that seems like a really good idea. It seems like something that TCP has evolved over how many references over the course of the last 5 decades, right? And I often find that actually it's easier to find what I'm looking for by going through Wikipedia than starting directly from the RFCs myself. There are often good Wikipedia pages that will summarize the evolution in that way. And so some people are actually going out there and doing this by hand already because that's who's constructing the Wikipedia stuff. But more broadly, talking about using AI in this, I find that the harder the question, the wronger the LLMs are. Because with the simple questions, there are a lot, the training data that's out there on the web is largely correct, and so it can pull from that and get it. But the harder the questions are, the more wrong information there is out there on the internet, and the LLMs are not good at finding the good information. And to me, this seems like a pretty fundamental problem. Am I wrong about how fundamental this actually is?
I can comment. As I mentioned before, I don't know what is the term, but I call it entrenched hallucinations. So
I liked that term too. That was very good.
Yeah. So the thing is that, so you are an expert in the domain, so you are the judge. So to you, it's evident. I mean, sometimes it's not so evident even, like you need to really dig in. For instance, for me, I have been tinkering with RFCs from the core working group, which is the one I'm chairing. So I know, and we have a lot, by the way, maybe not as much as the TCP IP stack. Anyways, the thing is that it takes a lot of effort to spot them after a while, even if you fine tune your LLM to be more accurate, and still you get hallucinations. And I would imagine for someone, even in the domain, so I'm not talking a totally a new person. For them, they are not going to see, they're not going to know. But even for someone that is somehow experienced, still is pretty hard to spot. And it seems to me like a fundamental problem. That's why I distinguish it from the other that is more like engineering. Like that one is tractable. This one is, I don't know. And with agents, you get compound errors. So it's not one call to a zero-shot LLM. It's more like a reasoning agent that is calling LLMs 10, 20 times to answer your question. So it might be even compounding. So it's a pretty tricky problem. But if you are a domain expert and you already know kind of like how it is, you can judge faster and it can help you in your processes. And for that, I think it's definitely a pretty good use case.
So the thing is, I don't lose sight of the fact that LLMs are a piece of software. And then the obvious observation is software has evolved over the years, and it has gotten better and better and better. 5 years ago, no one was expecting decently that Sora AI was going to give you 5 seconds of slop, because it's slop, but it is frankly amazing slop. And for the purposes of, you know, going through a reel and having some laughs for someone who just came up with a very funny idea, it's more than sufficient. Now, what's going to look like in 10 years from now? I mean, there's very serious conversations about Netflix turning into a prompt-based service. Build me a movie that is going to be having, you know, some mystery and whatever, and my kids can watch. Go. And half an hour later, you have a movie. Why wouldn't you? I don't want it. It's not a product that I'm interested in. The thing is, I'm not representative of what the rest of the world is going to be interested in, and specifically new generation. So the question that I'm always asking is, what is the counter argument for that not to happen? And so when I expand that same question to protocol design is, okay, right now we are not at that point, but what's going to be the counter argument for companies to think, I'm not going to be spending, what, $200,000 a year to participate in ITUT processes for I don't know how many years, for I'm not 100% sure what's going to be my return, when what I want is to be able to have node A and node B talking to each other and solving this particular problem under these particular circumstances. Go. And I don't care if it's 1 millisecond loss or I gain 5. It might not be interesting for that particular use case scenario. Again, the sufficient part is what I would trace the line. So I don't see exactly how we get away from it. So the question is, what do we do to prepare so that it is not biting us in the ass moving forward?
Thanks.
I think Colin is the next in the queue.
Okay, can you all hear me?
Yes.
Yep.
Yes.
Okay, great, thanks. First of all, this is a really interesting discussion, so thank you everybody for that. One of the questions in the introductory talks was how might we structure RFCs to be LLM friendly? And I think Joseph touched on this a little in the discussion afterwards, but I'm wondering if the panelists have a feel for the extent to which formal methods might help with that. I'm thinking in the way that vibe coding works pretty well with strongly typed languages, because the compiler can check the result and you feed that back to the LLM whether it's worked. And I'm wondering whether more structured, more formalized ways of writing RFCs would then help the LLMs with modeling the protocols.
Maybe one quick comment. Things like RDF and any kind of enriching from the normal markdown helps. ABNF, we have plenty of ABNF in the RFCs. That could also help. Any kind of formal language helps, but I'm not it's not my thing. Maybe others can comment.
I think Joseph was about to make a comment.
Yes, I'm just setting down my volume for that. So there's already a significant use of pattern languages in different fields, particularly, I mean, there's whole sections in bookstores on books about pattern languages for this and that. It might be useful for the IETF to explore, maybe there is already a pattern language for RFCs that might help to structure the way that they're expressed. It would be useful for the work that we're doing, which is not at that level. It's kind of a lower level for the individual rules, but it would help to structure both how the human thinks about the RFC and the particular rules, as well as how the LLMs as linguistic tools, not as oracles, how they process them into summaries and so forth. In fact, that might actually be a pattern language like that could be given to an LLM and say, express this section of the RFC in this given pattern language.
Yeah, that's pretty much what I was trying to point out when I was mentioning about the Royal Academy of the Technical Language. So once you're going to be defining processes that you expect to happen or that you want to not happen in a given RFC, the idea would be to put them to frame them in a way where those terms are going to be stable across time, and which definitions are going to be agreed upon across all the technical community. And that's the standardization part that I see where the IETF actually can get work. We have RFCs defining what shall not, must not, because it was a problem in terms of interpretation. So the question is, do you think about Yang? Yang is a language that's basically used to program how an interface is going to work. So how do we make sure that those words, those keywords, remain stable across time to make sure that those standards, when ingested by LLMs, produce as much coherent outputs as possible? And whenever they're failing, then we identify those problems and we ask whoever is building that technology to please, do something different so that it converges better. And that was part of, as well, one of the topics or bullet points that I was mentioning over there is that maybe the IETF should do some work, I don't know in which capacity, to be able to establish which models are behaving better in terms of outputs for IETF LLMs. And I'm not talking about promoting or anything, but in terms of giving a rank, whatever the hell. I don't have an answer to that particular question. I just think something that the IETF has to look into.
I can say something. I think you can use the current existing AI like ChatGPT to function as a reviewer when you write something for the RFC. Because when we write something for ourselves, we think it's very clear, but it's actually not for the other audience. So if you use large language model as a third party to tell if it's written clearly or not, or if it creates some misunderstanding or not, I think currently you can use it as a reviewer, And I know some conference like AAAI, they already start to utilize large language model to as a paper reviewer. I think that can help to help the internet draft to be written more clear. Yeah, that's my opinion.
Yeah, I think the idea of structured test cases is a really interesting one to think about, and I find it amusing that unstructured language tools potentially push us to writing RFCs in a more structured way. But thank you, everyone.
And I think that Sue is next in the queue. Hi, Sue.
Thank you. Colin's question will lead into mine. Having worked with Yang or done several complex Yang models, and having had,
So can you speak a little bit louder?
sure,
Closer.
I turned down my mic. I turned down my headset due to the other static. How is this, Alvaro? Is it better?
Yeah, a little bit better. Thanks.
Let me try to up it a little bit more. How's this, Alvaro? Better for me?
Yeah, sure. Go ahead.
Okay. So again, Colin's questions lead into some of mine, as well as the people who've noted Yang and some chat GPT. You know, automation has had, for configuring and managing networks, has had some spectacular failures. I reference, see the news. If you've looked at Amazon, if you've looked at some of the large companies who have used fairly well installed automation, they've had failures. And you're pointing toward automation as things that prove that this works well. And the problem about some of those failures is people didn't expect what was going to happen. Okay. ChatGPT, on the other hand, has had some people concerned about its security and where the data goes. So those are two really issues. Both of the crises have two portions. They have the screw-ups by accident and the screw-ups by malintent. When you start to use tools like this, I don't see in your design, in your discussion, the failure discussions, okay? Because LLMs have a tremendous amount of power, but they have a tremendous potential to hit new crisis points and new spectacular failures and new security points. So as you're heading this direction, even with the RFCs, you have issues. You're suggesting a template approach, which I am 100% behind, because I write templates for people to write RFCs on, because otherwise I get, as a reviewer, I have to repeat myself. You didn't put in this, you didn't put in this, you haven't explained this, and therefore it's not either a good Yang model or it's not a BGP good text or etc. So I'm really behind the LLMs to try to help us do a better job, but I'm not seeing the realism on the tools. And if you could discuss that, I'd love to hear it.
I would like to comment. You can hear me?
Yes.
Yeah, very well.
So I'm curious, when you say you're not seeing the realism on the tools, you're referring to the LLMs in particular, and I'm wondering if when I kind of step through the particular method that I described very generally, does that help to address the issue that you're talking about? Because you do favor using templates. So I mentioned using like a pattern language for RFCs, but also then this lower level rules as data structure, which is very constrained. It's unlimited semantics, but it's a very constrained expression grammar in order to not replace the LLMs, but to structure the messaging so that it can get to people who, while they're doing unit tests, and incorporate the substance of the LLMs in, as messaging into whatever development environment they're in.
No, is the short answer. No, I didn't feel you provided enough background. I realize unit tests, you described unit tests, but I do not think you really looked at the failure points. And by the way, if this is research in your beginning, I'm not knocking the research because of it. I'm pointing out additional work that needs to be done in certain areas based on failures we've seen with Yangs, or failures we've seen with automation, or failures I've seen with templates. Unit tests test templates. There are always places where templates and unit tests, when you don't think about them right, cause failure. And the further back you go, when the templates and the automation is creating the things you're using to take networks, that whole process has to have a moment of thinking outside the box, okay? And looking at crisis points and looking at loads. Otherwise, you have a problem, okay? For a while in the 2000s, I ran a routing company that developed routing softwares on a CD. And one of our claims to fame was a fairly substantial unit test that other vendors didn't have. But what you find in all of that, I'm giving a past example so I don't pejoratively point toward anything in your current work. So please pardon me, an old example. But what we found is thinking outside the box was necessary. Thinking about crisis points was necessary, and thinking about how you do manageability. Now, so I hope this begins to show you where I think additional research, and research is really useful in this area, might benefit both this and the use of it for RFCs.
Just a quick follow-up on that. So just in terms of the work that we're doing, my colleagues and I, this is, I guess, beyond research. There's actual running code on all of this. I did 10 years of research on the doctorate, which was find that online at xalgorithms.org for all of the substantive research in the background on this. But what I was presenting here was a very particular use case for this method, but there's other conversations using this data with direction specification for trade rules, central banking rules, all sorts of rules. I was particularly focusing on how could you auto-generate prompts on development environments when somebody's actually writing code, so that they can incorporate, much more simply incorporate RFC standards conformance on the fly, and sort of be informed of that. Not to automate the injection of anything into their source code, but just be prompted saying, "Oh, actually, there's a rule about that. You didn't, that is kind of being violated by the way you've structured this." Just enabling that sort. So that aspect of it has not been implemented, but the background method is up and working right now.
Maybe I can, like I was just thinking, based on the discussion, how things will become more real and tangible. I think a lot of it is already happening organically. So for developers that are using Cloud Code, Amazon Q, or whatever, prefer agent locally for coding, the bar is super low in order to use it to write your drafts or edit your drafts or get feedback and so on. That is really easy to adopt it. So some of it will happen organically. The IETF could help maybe in some of the infra, as I mentioned, like on the IETF backend, you could do tests. But I was thinking maybe a more ambitious goal based on the discussion about LLMs being not accurate. Like there is a process called fine-tuning, And for that, you usually have expert feedback and you have Q&As. Essentially, you write questions, you write also the answers, and you verify what the LLM has been answering. So it could be an interesting exercise, and I throw it out there, to get some experts from IETF for various working groups and start fine-tuning some model to be more accurate, basically. And then you can have some fine-tuned LLM that is really, really, really good at understanding RFCs, for example. I don't know if anybody has done that, but that it sounds useful. And then you could get a smaller model also doing that. It doesn't have to be a super large one, actually. And fine-tuning is much cheaper. It's not training, right? So it's actually not expensive to do some fine-tuning. Anyway, just an idea.
If you're really interested in that particular problem, I have a couple of things that I'd love to talk about offline on, a couple sets of RFCs that I'm nurturing in BGP that might well do for an LLM, because I'm trying to get people to follow the templates. So we have templates, and I have a set of 20 plus RFCs that need to use this template. So if you're interested in an LLM, I'd welcome an experimentation. Thank you. I'm sorry to add on to the queue. I just thought I would respond with a positive nature of, sure, I'd love to see it. Let's try it.
If I can interject in here, just to add something to what Sue was talking about, I found really interesting the fact that Joe and you both selected BGP examples. I happened to be the AD that published BGP Sec, the work that Yi was doing, and we published that other RFC on the thought process, because the process was very contentious, and so we didn't want this to be opened every other meeting if we could avoid that. So we published that other RFC. It turns out that Sue's working group, which is IDR, the BGP working group, just opened 4271, the BGP spec, the base BGP spec, for a revision, so that we're going to elevate it to internet standard. So to me, this was really interesting, because if you're, Joseph, looking at the analyzing the text in 4271, and we are now revising it, it seems like a good potential synergy there to directly influence the work that is already being done. The plan is in the next year or so to revise the draft. And I'm not trying to put more work on IDR or anything like that, but it may be interesting for the editors. And I know, Sue, you're on the editor team.
Yes,
to look at some of that output from Joseph's work related to 4271.
And I have the original text, the BGP issues for the first generation of the BGP, which would be wonderful to have somebody try an LLM against it. The set of work I was working with, Alvaro, is the BGP LS and the SR. That is a case where I have up and coming RFCs that could use some of this approach. And I'm willing to give it a shot. If it helps, we get better RFCs quicker. So if both of those, I'm willing to help either Joseph or someone else working on it, because I'm interested in both things.
I'll be very happy to collaborate on that. And I'll just tell you a little test that I ran yesterday preparing for this. So I actually, the LLM I use least is ChatGPT. I'm frequently using Lumo, which is provided through ProtonMail. But I gave Lumo the DWD array, and I gave it the DWD coordinate, and I told it where I'm getting it from. I activated the web access, and then I instructed it to go searching around RFC 4271 for some other rule, and then represent that rule in this method. And I had to go back and forth a couple of times because I'm using just a generic LLM as such, but it generated what seemed to be, as LLMs are, a reasonably competent summary. Now that's just I didn't, I think if we focus on the template design and prompt engineering to get reasonably good answers from any of the significant LLMs, actually any well-trained LLM, because we can't tell people what LLM they got to use. If we can provide some good prompt engineering, we can get it to the point where the LLMs do the boring grunt work, and then we can take a rule and have a human and checking, is this, what do I need to adjust in this to make it exactly conform with what the rule intends? That would be fun.
So I wanted to quickly address Sue's concerns about, when bad things happen. We tend to think about trying to have human in the loop when it comes to flows. But in those circumstances, what I like to think about is human as a subject. So you give me that use case scenario where you're concerned about, possible bad outcomes, and I'm just thinking, just switch the machine for a human. So how did we solve that particular problem when humans were the ones who were doing that particular situation or involved into that? And I really don't see how it is any different from the learning process that we had in many other areas, such as, I don't know, building bridges. We one day decided that it was a cool thing to build a bridge to be able to shorten time crossing from A to B. And then the first designs were a disaster, some people died. And then we got a code about it, and those codes were still not sufficient. And as time passed, we just made them better. And it's a matter of someone is going to suffer across time for those new technologies. There's nothing you can avoid about it. I mean, I'm not wishing for it. I just don't see how you can change the way that we have ever progressed in any single industry or any single engineering, whereby some people are going to have a hard time and others are going to figure out a better way to solve the problem, and we move on. So, I mean, LLMs are the result of the first. We always try to use technology in order to solve problems that are useful for humans. We have never invented anything that is not specifically useful for humans. And we moved into having this new approach for neural networks, what, 20, 30 years ago? That's when the boom was coming up. And what we were trying to replicate? Humans. So what are we expecting? Behaviors from pieces of software that are going to have characteristics that are human-like. Anthropic did publish a paper, 3 months ago, something along those lines, where they were proving that once a model was trained, it was very, very difficult to change their mind in certain areas. Basically, they're stubborn. Well, stubborn seems to be a feature of the way that we have created the models with through GPTs. Well, tough luck. If we don't like it, we're going to have to invent something else. And so there's no getting away from all the problems we're going to have in order to get the technology better. I don't see a solution for that.
I think Harry is the next on the queue.
Jariak, yes. So thank you for this very interesting topic. I was inspired by the difference between the sort of short-term focus and then more long-term visions. I'm very much in the same boat as Jaime. We've been working together, of course, so that's not a surprise, practical stuff. But we're also very interested in the long-term results. And I have two questions for the panelists. What do you think are the factors that influence the future? Seems to me that there are some constraints. You mentioned non-determinism and so on, but also like we sometimes don't have all the information in standards. We have things beyond the standards that you have to know, even for interoperability or for efficient implementations. You have the question of general fit for problems. Not all solutions fit all tasks, right? You have different tools. Maybe the AI isn't the fit for all possible problems. Can you compete with sort of classical implementations tuned for decades? And secondly, if you get to this feature, where does it exactly take us? So if you compare the companies programming, whether programmers program faster, what does it mean? You need less programmers, but there's competition. So in the end, maybe you have to produce 10 times faster and the next release, or maybe you need to do more. For us, Is it more functionality? We need to do less effort at least, or we have more tailored protocols for, for that situation with 2 parties versus that situation with 3 parties? Or do we give up with standards to some extent and, everybody can just do their thing in their particular context? And, what is it?
I can go first because I'll be brief because I'm sure you guys have much more interesting stuff to say there. A lot of this has nothing to do with AI, like the cycles are going faster. At least I can perceive how de facto standards, in 3 or 4 months reach consensus and become deployed. And in the meanwhile, the IETF takes 1 to 3 years, who knows? And then you have 3PP, takes 5, 6 years. So it depends. Of course, it also depends. It's a matter of quality. Personally, I think the IETF has really good quality RFCs. And that is appreciated in the long run, I think. So I do see AI making us do things faster and with a certain quality level. But at the same time, I could see things being completely changed in the way we work. Like, as I mentioned also in the presentation, I could easily see small group doing a code implementation and then the whole standardization process being generated, for instance, from the code or mostly. And I also see there is this kind of aggregation in smaller players, so you also need fewer people to reach a large critical mass. So all of that is happening. I don't know how much of it is AI driven, but just the way things are, the industry is changing. Yep, thank you.
I'm actually fascinated by the word that you used about determinism, because I'm wondering if that is an expectation that we have created across a number of years of current engineering methods, by which the same code base will always give you the same amount of a series of 1s and 0s, and I'm happy with that determinism. The question is, humans are not deterministic, meaning I may ask the same request to 2 different people, and the output might be different, but the solution may be sufficient even in both cases. In other words, I don't really care how Zoom functions or how Google Meet functions, for as long as the features are there. And what I would like from the perspective of our foundation is that there is a certain degree of privacy and so forth that is also enforced into those implementations. But how it is done is not really something that bothers me much. And in general, I don't think much users are going to be bothered in the list. And so the determinism part, I understand because it's a part of alignment, really. Is this piece of software generating something that is aligned to what I'm expecting to have? And in the terms of hallucinations, what I find, I don't know, it's kind of a joke for me because we keep reinventing those terms by the industry. We used to call hallucinations mistakes. That's what a human does. We mess up. It's not exactly what the right answer, and I'm not hallucinating. But okay, the industry used that term. I'm fine. I'm not necessarily criticizing it. I'm just thinking we already had a concept for that.
Can I add something in between here? So I think there's a distinction between like where do you use some of this technology. So if there's a human in the loop, then there's usually not a problem at all to have some mistakes or non-determinism or hallucinations.
For as long as the human knows what they're doing.
As long as the human knows what they're doing and they actually do check everything. But then if you're talking about a box that does something like a router forwards packets, trillions of times per second or whatever, you can't have any appreciable error rate there, or otherwise, things will go very, very badly indeed. So it is about the level of involvement that the human has. And obviously, like we know that we are all lazy, right? So, at some point we start trusting things that, and maybe that's okay also to some extent. Like we are engineers, we can design, fault tolerant systems that one thing can fail and the whole thing and your transaction will still succeed. So maybe that's what part of the answer, but it's kind of complicated.
See, so the tolerance level, that sufficient concept is what brings into it. And when you were thinking about whether standards disappear or not, I keep thinking as well into Harry Potter. So engineers still will have to go and learn because even if they wanted to become magicians, wizards, or whatever the hell they are in the Harry Potter universe, they still go to school. And they have to learn specific spells, which are basically the specific prompts that you require to get the output that you want. And so I do see the need that there's going to be a number of engineers that are going to be maintaining that infrastructure, that abstraction layer that makes that possible. And then a series of people where their careers will be, I'm going to learn now how to use that magic technology to be able to will whatever we want to create.
Regarding factors affecting the future, I think, I mean, there's going to be all sorts of interesting and useful methods arising. There's going to be the failures. There's also going to be the more sophisticated abuses. And those abuses are not necessarily even intended abuses. We all, I'm sure, know people who've done some innovative work, made the effort to put it into a formal article, but the established publishing bodies don't publish it, whether that's through a decision of an editor or whatever. But there's a lot of excellent work that is not published by the leading publishers based in the G7 countries and so forth. So there's a kind of a built-in bias in whatever things are trained on, and that includes the whole problem of trolls. I have had some innovation that I was kind of doing a bit of testing on. Sometimes I'll just take it and say comment on the following, and I actually recognized some of the criticisms from trolls back about 6 years ago that we're making comments, which is fine. I didn't mind it because I recognize it, but what gets embedded in this is both the absence of things that were not published formally, because then it's not necessarily available. I'm not sure how well these are trained on some of the more open access unstructured sources. I think also when I'm doing the technical work when we're doing the technical work on our stuff, data with directions. So this is using tabular declarative programming. That was very popular before computing was big, right? So that was big in the 1960s and 70s. So we were drawing upon older material, but very few of the LLMs have any access to the data structuring that was so brilliant back in the 70s when networks were slow, hardware was slow, but financial institutions were rushing to compete on automating the financial services sector. All of those are gaps which the current LLMs have difficulty being up to date on.
Okay, thank you. Nicola, you're next.
All right. Hi, Nicola, Sign Association. So earlier you opened your talk, I think, James, with saying that you should not delegate understanding to LLMs, which is something that I fully agree. But then later on in the discussion, I've also heard, okay, maybe we can build some specialized LLMs that are fine-tuned and that can actually understand. Okay. Okay, yeah, because I was a little bit confused about, the optimism, because in my experience, these tools are good at small tasks, but when it comes to understanding, we're really not there. So I was curious on your opinion on, okay, are we going to get there and when? And in the short term, then what can this be employed for? Which
Use the mic.
Oh, yeah.
Sorry. So I'm not an LLM expert, but to me it's a statistical thing, right? It generates tokens and it's not understanding. I don't know what the AI folks, I mean, those guys are doing amazing stuff. I don't know what they will come up with, but for our own sake in the work we do, we need to understand. And precisely because it will not always be correct. So if I said understanding, I didn't mean that. I mean, like, okay, you could fine tune an LLM and make it smaller, also like with few billion parameters. I heard, actually, yesterday I had a meeting with someone from Qualcomm mentioned that there is small language models, 8 billion parameters that seem to be performing really, really great. And I could foresee people in the IETF taking all the RFCs and fine-tuning, meaning like having Q&A with the experts to evaluate the outcome and improve the performance of the LLM. But still, it's not understanding anything. Still, it's just
Okay, that makes sense.
summarizing in a better way, or whatever you want to call it.
All right. And then second question, do you know if there's any policies or discussions on any policies on the use of LLMs for authorship, like attribution, or because I'm pretty sure that many people do use them? And
that's a very good question. We have internal policies for some of the, so every company has policies for the code they generate or they use for generation. The IETF, I'm sure they have other policies as well. In generally, I guess the IETF, the information is public on the internet. So, I mean, every LLM has been trained with IETF data for sure.
Yeah, I'm more thinking about authorship, or
authorship,
should you disclose if you're?
We could put it. I mean, I'm tempted now to put it at the bottom. Like at least acknowledgement. Like a lot of this was reviewed by Claude. Thank you very much, Claude.
Yeah,
why not?
Yeah, so actually, really quick, and Dirk and Colin can help me out here. So I believe in the IETF Code of Conduct, maybe, there is a section about AI authorship. And I believe what it says, if I remember correctly, is that if you had the LLM write the RFC for you, the draft for you, you should say that.
Well, just to be clear, like the LLM is a thing, so it's not really an author, but you can, like, thank you for this tool. You can thank the company that built the LLM, I guess, or I don't know.
Right, so it's different to
a very meta topic.
Right, so it's different to use the LLM to help you with your grammar and make it clearer and things like that. It's a completely different thing to say, hey, write me a protocol that does interdomain routing, right, or something, and publish that in your name. That's a different thing.
Yeah, of course.
We reached that stage. That will be amazing to watch.
Popcorn. All right, thank you.
I have a comment about a future opportunity that we've had in mind from the very beginning, designing what we're doing, is the accessibility of standards to people whose first language is not English, and English may be a third language for them, and who will have difficulty understanding many of the nuances. So when we did our testing of the constrained grammar, we actually tested that on now, I think, 26 languages, including very different languages like Korean and Thai, and by restricting the grammar, it forced basically we were able to get the essence of rules expressed in a correct way for native language speakers in many different languages, so that messaging about rules can be delivered in a summary but human reviewed way to developers in their native language, even when they're trying to conform with the RFC, or any other standard, which is in English.
Ms. Moran, Michael.
Hello, Michael Welzel. I see that the discussion has been going back and forth a little bit about things that are more longer term, futuristic, like you've been talking about these things quite a bit, and some that are more lower hanging fruits and things that we can do at a more immediate level. Now, there has also been talk about the concern of LLMs hallucinating and making errors that stick. I believe in the more nearer term, we can use LLMs in ways where hallucination just doesn't matter. One should not make the mistake, I think, of thinking that LLM needs to be equated with generating text always. You can use it for all kinds of things. You gave the example of structuring RFC text better by finding out inconsistency problems between must and should and so on. The things that we're doing is trying to find reasons that are behind, that GA is working on, reasons behind that led to certain text. All of these things can help us write RFCs better. Also the things that Joseph is doing, right? Finding out, determining rules in the text. I think the thing that we should focus on in the near term is to write clearer, shorter, more precise RFCs and let LLMs help us in doing so. And maybe as LLMs help us in doing so, this will also help us make the text more LLM friendly, which is what Colin and some others have been wanting. So I think that should be the direction of what we should be doing as the IETF in terms of producing better specifications, rather than worrying too much about the long-term future and dreaming up things that may happen or may not happen. Let that evolve, and when it comes to it, it's going to be better anyway. Right? That's my take.
Yeah, I tend to agree. Yeah, I think the low-hanging fruit is low, so let's grab it.
All right. Thank you very much. Can you hear me? Hello? Okay, thank you. So my name is Kunle Olarundare from Nigeria, and it's a pleasure to be in this particular meeting, and I listened with rapt attention. I think this is really good. As a matter of fact, my comment was supposed to be on Joseph's session, but then I think maybe there wasn't time for comment as at that time. So I just want to make this comment, and it's all about the use of the artificial intelligence, so to say. Yeah, I know that artificial intelligence has grown in leaps and bounds. Obviously, there's no gainsaying that. However, we also need to come to terms with the fact that, yeah, it's still something that is growing, and yeah, it's good if we're using it, but then we need to be a bit careful in the sense that as it is now, it's still growing, and peradventure, it may not be able to give us 100% perfection in whatever we are using it for in terms of application and so on. So I just want to throw that word of caution into the air so that at least we take note of that. Thank you very much.
Okay, I want to mention something about the fine-tuning. So the fine-tuning is not about giving the...
We need you to be a little bit louder. Yeah, thank you.
Okay, so I want to say something about the fine-tuning. So the fine-tuning is more than just give the model the input and output. So if you want to have some trust from the large language model, you should also provide your reasoning, or it's called thought process. Like what's the background stories happened for the input and output. So it will help the model to learn how to reason. So I think if you ask the large language model to give you not only the answer, but also its reasoning process, you can see how it works. It's not like a fantasy or hallucination. Yeah, that's my point.
Maybe that's a very good comment, actually. Like I'm not an expert. I'm not an AI expert, but the precision and the accuracy. Just a moment, we have a local problem here. I don't know. That was fun. Yeah, I was just going to say that I'm only familiar with this chain of thought and reasoning and acting planning that is LLM based, but I'm sure there will be, there must be even better ones coming. And yeah, the progress in that side has been amazing.
Well, maybe that's a good time to to wrap up the session. Looks like we are having external forces pushing us to wrap the conversation, but looks like there are no more questions. So maybe let me wrap up by first of all thanking very much to the speakers, Joseph, Jan, and Jaime, for the very interesting discussion, and of course to my co-chair Alvaro for being physically there, and to everybody who jumped into the mic or to the chat and contributed to the discussion. Hope the conversation keeps continuing. It was very interesting. Thank you very much, everybody.
Thank you all. Looking forward to following up on these conversations. Cheers.
We hope to see you all at the next meeting, either in person or remote in Shenzhen. Thank you.
As I sit and listen, I realized I would have recognized you quicker with my eyes closed.